Hi everyone and welcome back to my channel A in Economist. So in today's video, we are going to solve some questions on the multiple linear regression model in matrix version. So let's straight away go into the question. The question is this: an economist is analyzing the impact of education and experience on the individual wages. So individual wages is the dependent variable here, and you have two explanatory variables, education and experience, right? So you have two independent variables or explanatory variables and one dependent variable. Hence, it is a multiple linear regression model where you have more than one explanatory variable in your model. Now she collects the data from three individuals. So you have n equals to 3. Sample size is 3. And the model of the wage equation is given as this: y equals to x beta plus u. This is the usual multiple linear regression model where y is a 3 cross 1 vector which represents the wages, right? Y is basically a vector, dimension is 3 cross 1. Now x, here this x is representing the design matrix of order 3 cross 2. So x is the design matrix, and where the first column, where the first column of this design matrix represents the years of education, and the second column will express the years of work experience. So X is the design matrix which has a dimension of 3 cross 2. So basically 3 rows are there and 2 columns are there. In the first column you have the years of education, and in the second column you have the years of work experience times beta curl. Beta curl will be the vector of parameters. You have only two parameters here, so 2 cross 1 plus U curl. U curl is the error vector, basically the vector of error term. So this will also be 3 cross 1. So this is given to you in the question. So basically, if you write this in the matrix form, this will look like this: y1, y2, y3. So this is basically the individual wages of these three persons that you are taking into account. And here you will have the design matrix of 3 cross 2. So here you will have x11, x12, x21, x22, and x31, x32. So design matrix looks like this. Into the parameter vector, you have only two parameters, namely beta 1 and beta 2. Suppose I call the parameters to be beta 1 and beta 2. This is what basically you need to estimate, plus the error vector, which has three terms, u1, u2, u3. So this is the entire matrix representation of this thing. Now, here, certain data is given to you. In order to solve this question, in order to make any progress, you need to have the data. So in the data, they have given you what will be the y curl vector and what will be the design matrix, right? See here, so y curl is this, y1, y2, y3. See here, this is the outcome vector, basically, vector of individual wages. So they have given you y1 equals to 50, y2 is 60, and y3 is 65. You can match it from here. And see here, you are giving the design matrix, which is given as this. So the first column here, 10, 12, and 16, it represents the years of education. So the first individual has an education of 10 years, second individual 12 years, and the third individual 16 years. And the second column represents the years of work experience. So the first individual has 2 years of work experience, second individual is 4 years, and for the third individual, it is 6 years. So this y and x, these two things are given to you, and we will assume the error vector. The error vector follows a normal distribution. Mean is 0 and variance is this, sigma square into the identity matrix. So essentially, our model looks like this: y equals to beta 1 education plus beta 2 experience plus u. See, match it from here. So this is the matrix representation of this entire thing. Now we have to answer the following questions. What are the questions that we need to answer? These are the questions. So I have, set this question in such a way that you get a holistic view of every aspect that you can be asked of in your exam in this matrix version, right? So in taking into account only two explanatory variables, you can extend this to three explanatory variables, four variables, and so on. For simplicity, I have taken into account two explanatory variables, and you need to answer all these following questions that we are going to solve one by one. So let's take a look at the first question. It says, estimate the parameter vector that is beta cap. So see, You have two parameters, beta 1 cap and beta 2 cap, which is given by this beta call vector, which is 2 cross 1. Dimension is this, beta 1 and beta 2. So basically, you have to estimate this parameter. Estimate these two parameters using your data set and the given model. So if you remember, we have derived what will be the estimated value of beta curl cap in case of OLS estimation in the matrix version. So that is why the theory videos are very important. I have uploaded 4 theory videos as of now. If you haven't watched those videos, please do that. Otherwise, you will not understand, how to get these formulas, right? Here I am not deriving the formulas, that is already done in the videos. I'll give them in the description box. Also in the I tab, you can check the videos out. Here I will directly apply the formula and show you how to do the calculations. So basically the OLS formula or the OLS estimate of beta is given by beta curl cap OLS, that will be given by x prime x inverse x prime y. Right? I hope you remember this formula. We have, in details derived this. So now this X matrix is given to us. See, X matrix is given to us. X is the design matrix. The matrix is given to us. All we need to do is to calculate this thing. So firstly, find out what will be X prime X. X prime means X transpose. So if you transpose the given matrix, it will be this 10, 12, and 16 will come here. And here you will have 2, 4, and 6. So transpose means convert the rows into columns and convert the columns into rows, nothing else. And here you have the original matrix 10, 12, 16, and then you have 2, 4, 6. Now you have to do the calculation. So what is the dimension of the first matrix? X is 3 cross 2. So it will be 2 cross 3 and it will be 3 cross 2. So the matrix that you will get after multiplication, it will be 2 cross 2. So how do you calculate? So take this and do the multiplication and just calculate. So first thing will be 10 square. I hope you know how to calculate. 10 square, then it will be 12 square, then it will be 16 square. The first element is this. Now this and this. So first term is 10 into 2, which is 20. Plus 12 into 4, 48. And plus you have 16 into 6, which will be 96. And here in the next line, you have this and this. Take these two things. So first is 20, then you have 48, then you have 96. And this thing, if you do 4 plus 16 plus 36. Now, if you calculate, if you do the calculation, you will get this x prime x will come out to be, you can do the calculation. I have already done this for you. This will come out to be 500, 164, 164, and this will be 56. Right? So this is the first part. See, we have calculated x prime x. Now we have to take the inverse of this matrix. Okay, let us firstly find out what is x prime y curl, and then we will take the inverse. X prime y curl. Prime means transpose again. So 10, 12, 16 is there. 2, 4, 6 is there. We have taken the transpose. And then y is also given to you in the question. Y is this. So 50, 60, 65. 50, 60, 65. Do the multiplication. Here you have 2 rows and 3 columns. And here you have 3 rows and 1 column. So it will be 2 cross 1. This vector that you will get, it will be 2 cross 1. You can again do the multiplication. Take this row and multiply it with this. I have done the calculation. The answer will come out to be 2260. And take this row and this column. Here you will get 730. It's simple matrix multiplication. I am not, writing all the values. I hope this much you can do. Right? So we have this now. According to the formula, what we need, x prime x inverse x prime y. Now we need to calculate the inverse of x prime x. So x prime x inverse will be simply adjoint of this matrix upon the determinant of this matrix. Now the determinant of this matrix will be simply 500, 164, and 164, 56. If you take the determinant, simply this minus this into this, minus this into this. If you do this will come out to be 28000,26896. You can do the calculation in your free time. 1104. This will be the determinant. And then how do you find out the inverse? Calculate the adjoint for that. In adjoint, in case of 2 cross 2, what you do? Simply replace this with this. Interchange these two things and put minus in these two things. This is the formula. So basically, 56 and 500, they will interchange their position and remaining will have a minus sign before that. This is minus 164, this is minus 164. See, what we have done here is that this and this, these two elements will change its position. So 56 will come here and 500 will come here. And the remaining two components, they will have a minus sign before them. And this will give you the adjoint of this matrix. Now you have adjoint and the determinant, so you can find out the inverse. X prime x inverse will be simply adjoint of x prime x and the determinant of x prime x. So it will be 1 upon 1104, 56, 164, 164, and 500. Now again, I have to do the calculation. I have already done the calculation. Let me directly write. Six, 840, and this will be minus 5640. Okay, so this is the inverse basically, right? Inverse. Now what you have to do, you have to find out the beta cap OLS. See the formula, beta cap OLS is simply inverse times x prime y. So let us do that. So beta cap call OLS is simply x prime x inverse into x prime y, where this x prime x inverse we have just found out 1104, and here you have 56 minus 164 minus 164 500, which is this, into x prime y. X prime y, see, we have calculated this here. This is x prime y. So this is 2260, and then you have 730. Right? So once you calculate, now you have to do this multiplication and calculate. So beta cap OLS, this will come out to be 1104, 6840, and this will be minus 5640. You can do this calculation, multiply this matrix with this matrix, you will get this figure. And now if you divide this by 1104, this will come out to be 6.198, and this will come out to be 5.109. right? So what you can say from here is that beta 1 cap OLS is simply 6.198. This is the estimated value. And beta 2 cap OLS is coming out to be minus 5.109. So what will our model become? Our model will be this times education plus minus 5.109 times the experience. So this will be, and plus the error term is there, So that is how we have estimated these two values. If you see from this model, we have successfully found out what is the estimated value of beta 1 cap and beta 2 cap, which is part 1 of our question, right? Estimate the parameter vector beta cap. This is done. Now let's move to the second part of this question, which is asking compute the fitted values of y cap and the residual u cap, right? So let us see how we can proceed with this. This is part B. So fitted values will be simply x beta cap, right? The model is y equals to x beta plus u. So if you want to find out the fitted values of y cap, basically y cap is simply x into beta cap. So now x is the design matrix which is given to you 10, 12, 16 and 2, 4, 6. This is the design matrix and beta cap you just found out here. This is the beta cap OLS you just found out. So this is 6.198 and minus 5.109. So if you do the calculation, you can do the calculation. I am writing the final answer. Final answer will be 51.762. Here you will get 53.94 and here you will get 68.514. Right? So this is going to be the fitted values. This is going to be the fitted values of y. Now another thing that you need to find out, which is the residual, which is u cap, which is simply y minus y cap. This is the second part of this question, which is the residual. So y values are again given to you in the question. Let me go back and see. Y value is 50, 60 and 65. So 50, 60, 65 minus this y cap values, which you just found out. 51.762, 53.94, 68.514. If you calculate, if you take the subtraction, you will get minus 1.672, 6.06, and this will be 3.514, right? So this is basically the estimated values. This is U1 cap, this is basically U2 cap, and this is basically U3 cap, right? I hope part D is absolutely clear. This is how you find out the fitted value, and this is how you find out the residual values, right? So from here, you can see the fitted values y1 cap, y2 cap, y3 cap, and here you get u1 cap, u2 cap, and u3 cap. So this portion is done. This is part B of this question. Now, see, the third part is compute the R square. R square, as we all know, is a measure of goodness of fit. Let us see how we can compute R square. The formula is the same. R square is simply ESS upon TSS. Now you can do this 1 minus RSS upon TSS because TSS equals to ESS plus RSS from that decomposition. This also we have made separate video how to decompose TSS. If you haven't watched that, you can check this out. I'll give the link of the playlist in the description. So please check this out in your convenience and you will understand this. Now, firstly, let us compute what will be RSS. RSS is simply residual sum of square. I is from 1 to 3. You have only 3% here, so I will be 1 to 3. Now see, we have just computed what will be this residuals. In the previous part, right? Part B, we have just computed what is U1 cap, what is U2 cap, what is U3 cap. So simply what you have to do, you have to individually take the sum of their squares. So the first residual that we got is this minus 1.762. Take the whole square and then plus. The second residual was 6.06. take the whole square and plus. Third residual is minus 3.1, what was the value? 514, and then take the plus. So this will give you the residual sum of square, right? We are taking the square and then summing over all the 3% i's from 1 to 3. Because our sample consists of only that. If you do the calculation, this RSS will come out to be 52.19. Just square them and take the sum, you will get this. And what is TSS? TSS is simply I from 1 to 3 yi minus y bar whole square. Now, how do you find out y bar? Y bar is simply 50 plus 60 plus 65 upon 3. So y vector is given to you, outcome vector. So from that you can find out the average wage basically. Y is the average individual wage. So you can find out uh, the mean of the wage of the three individuals. This is 58.33. Now how do you get the TSS? TSS is simply take the first value 50 minus the average that we just got and take the whole square of that. See, the formula is this. Summation I from 1 to yi minus y bar whole square. Take the yi values I from 1 to 3. Y bar is simply this and then square them. Take the summation. So 60 minus 58.33 whole square. And the third value is 65 minus 58.33 and a whole square of that. Compute this value will come out to be 116.66. So now we have the residual sum of square and the residual sum of square we have computed, total sum of square we have computed. So we will simply take the ratio and find out the value. So upon 116.66, if you do this, this will approximately come out to be 0.552. So approximately 55% of the variation of the outcome vector, which is the individual wage, y is the outcome vector, can be explained by the explanatory variables in our model, right? So this portion is done. Then the fourth point is saying estimate sigma square. Sigma square is basically the error variance. In the previous video only we have derived the formula for sigma square. If you remember, sigma cap square is simply RSS by n minus k, where n is the total number of observations that we are taking into account and k is the total number of parameters. And RSS is simply just we got here. See, this is the value of RSS, which is 52.19. And number of observation we are taking is 3 and number of parameters is 2, which is beta 1 cap and beta 1 and beta 2. So if you do that, this value is simply this, because 3 upon 2, the denominator is 1. So this will be sigma cap square. So estimated value of this is done. Now part E of this question is saying compute variance of beta cap and the covariance matrix of beta cap. Let us do that. Let us find out the var covar matrix. If you remember the formula of var covar matrix, we have derived this as well. Sigma cap square x prime x inverse. I hope you remember this formula. We have derived this. Now we have all the values here, 52.19, which we just derived here. Sigma cap square is this. And from the previous calculations, we have this expression also. What is x prime x inverse? If you remember, while estimating, we have found out this. X prime x inverse is simply this. So we can replace 1104 and then you have 56 minus 164 minus 164, 500. Now simply if you calculate, this will come out to be 647. This is minus 7.749 minus 7.749 and this is 23.641. Now, while discussing the var covar matrix, what I have told you is that the diagonal elements of this matrix represents the variance and the off diagonal elements represents the covariance, right? So the diagonal element is this. This is the first diagonal element. This is the second diagonal element. So the first diagonal element represents the variance of beta 1 cap. Only the variance of beta 1 cap. This is simply 2.647, which is this. This is the Var-Covar matrix. This is the Var-Covar matrix. And in Var-Covar matrix, the diagonal elements, namely this element and this element, these will represent the variances of the parameters that are present in your model. So here, this element represents the variance of the first parameter, which is beta 1 cap, which is 2.647. Second is variance of beta 2 cap, which is given by this diagonal element. So this is 23.64. And see, the off diagonal elements are equal. This off diagonal elements are equal. This will give you the covariance. Covariance of beta 1 cap, beta 2 cap, which is exactly same as covariance of beta 2 cap, beta 1 cap, which is given by this off diagonal element, which is minus 7.749. Right? This element and this element, they represent this and this. They are absolutely equal. In every situation, they will come out to be equal. And this is how you find out Var-Covar matrix and also identify what are the variance and what is the covariance between the estimated parameters, right? So this is done. And now let us go to the final part E of this question. We have solved all these parts. Final part is saying test the hypothesis. Test the hypothesis that H naught beta equals to 0 at 5% level of significance, right? So basically the individual parameter test, this is the final part of this question. Let us do that. So this is part F. So we have to test the null hypothesis beta 2 equals to 0 versus the alternative hypothesis beta 2 is not equals to 0. So basically the two-tailed test. So what will be the required test statistic? So the alpha is given to you as 0.05. What is the test statistic? Test statistic is T, which is simply beta 2 cap minus beta 2 under H naught upon the standard error of beta 2 cap, which under H naught will follow T distribution with n minus 2 degrees of freedom, because you have two parameters, right? Two parameters in your model, that is the n minus 2. N is 3 here, so 3. So basically 3 minus 2 implies T1, basically T with 1 degree of freedom. T distribution with 1 degree of freedom. Now you have got all these values. We have already calculated what will be beta 2 cap OLS, which is the first part of this question. We know what is beta 2 under H naught, which is simply 0. And we have just calculated which is standard error of beta 2 cap, means the square root of this variance of beta 2 cap, right? If you know the variance, you just take the square root and you will get the standard errors. So let us put all the values together and see what we will get. So standard error of beta 2 cap will be simply the square root of variance of beta 2 cap, which will come out to be 23.641, which is approximately 4.86. You can check this calculation. So the computed value beta 2 cap. What was beta 2 cap from our estimation? Let me go back and see. Beta 2 cap is this, minus 5.109. So minus 5.109 minus the value under H naught is 0 upon the standard error of beta 2 cap. Standard error is 4.86. So if you do the calculation, this will be minus 1.051. So this is the computed value of T. This is the T computed. So if you take the absolute value, this will be, absolute value is simply 1.051. And what is the critical value? Critical value T 0.025 with 1 degree of freedom. If you check from the, in your statistics books or econometrics book, from the T table, this will be something around 12.7. You can do the, checking. I have checked this from my book, which is very large, which is basically very large. So the scenario looks something like this. Let me draw the T distribution. This is something like this. The t distribution is always symmetric about 0. Now in two regions, you have the rejection region. Here you have one rejection region and here you have another rejection region. The critical value will be simply this 12.7. So this value is 12.7. This value is minus 12.7. So beyond this 12.7, you have rejection region, and here beyond this minus 12.7, you have the rejection region. And the rest of the portion is the acceptance region. This entire portion is the acceptance region. Now, what is our computed value? Computed value is 1.051. 1.051 is here, 1.051, which definitely falls into the acceptance region, right? Definitely falls into the acceptance region. So we'll say T computed is strictly lesser than T critical value. Critical value is this. This is the T critical. T computed is strictly less than the T critical value. So we fail to reject. We fail to reject H naught at 5% level of significance, and we can infer that beta 2 is actually equals to 0, which basically means beta 2 means the beta 2 C from the original model. If you look at it, beta 2 is C, the coefficient of experience. So if your testing is saying that beta 2 equals to 0, means experience, the variable experience is not a statistically significant variable. So let me write it down, which means experience or years of experience is not a statistically significant variable to explain wage according to our data, right? At 5% level of significance, right? So this is all about this question. So we have taken a hypothetical question and we tried to cover every aspect of the multiple linear regression model in matrix version using the dataset which is provided to you. And I hope that you like this video. And if you find this helpful, then do give me like and do subscribe to this channel AN Economist, because it takes immense effort to make these videos for you. And every week I try to make at least 2 lecture videos, full length videos for you and help you in covering your syllabus faster and give you clarity in these concepts. I know this concept might seem a little hard for some of you. That is why it's my job to make this thing simpler for you. And that is why I'm focusing on this numerical questions, because solving questions gives you confidence in order to grasp these concepts, right? So thank you so much for your time, and let's meet you in the next video.